For most of modern astronomy, Europa was treated like a beautiful maybe, a frozen moon circling Jupiter, bright, cracked, and silent. The kind of place scientists mentioned when they wanted to sound bold, then quickly moved past, because the real truth was hidden too far below the surface to prove anything. But that is changing now because James Webb looked at Europa in a way no telescope ever has before, and what it found should not be there so clearly, so specifically, and in exactly the place scientists were afraid to hope for. Beneath that frozen shell is an ocean, not a lake, not a patch of slush, but a real global ocean. And now, for the first time, the chemistry leaking out of that hidden world is starting to tell us that Europa may not be just another icy moon. It may be one of the most important places in the entire solar system. Europa is one of Jupiter's great Galilean moons, a world of ice and fractures orbiting inside one of the most violent gravitational environments in the solar system. On the outside, it looks deceptively simple, a pale shell of frozen water marked by reddish-brown scars and long, broken ridges. But that surface has been lying to us for decades, because underneath it sits something extraordinary, a global ocean of liquid water trapped beneath kilometers of ice and kept alive by constant tidal heating from Jupiter's immense gravity. That detail changes everything. Europa is not warmed by sunlight in any meaningful way. At Jupiter's distance, the sun is weak and the surface is lethally cold. But Jupiter and the other large moons keep squeezing Europa over and over again as it moves through its slightly stretched orbit. That flexing creates friction inside the moon, and that friction creates heat. Enough heat to keep an ocean liquid for billions of years. A dark ocean, a deep one, potentially containing more liquid water than all of Earth's oceans combined. And that is why Europa became dangerous to ignore. Once you have long-lived liquid water, energy, and time, the question of life stops feeling poetic and starts feeling scientific. The problem was that for years we were staring at that possibility through frozen glass. We knew the ocean was probably there. We did not know whether the chemistry down there was dead, sterile, and useless, or alive with potential. What James Webb did was quiet, but devastatingly important. It looked at Europa with one of the most sensitive infrared spectrographs ever built, and searched for chemical signatures on the surface. Not guesses, not artist impressions, molecules. The target was carbon dioxide, and the reason that mattered was simple. Carbon changes the whole conversation. Carbon dioxide on Europa's surface can come from outside or from within. It could be delivered by impacts and surface contamination from space, or it could come from the hidden ocean below, pushed upward through cracks in geologically young terrain, then left behind on the surface as chemical evidence of what the ocean contains. That difference is everything. External carbon tells you space is messy. Internal carbon tells you Europa's ocean may contain one of the essential ingredients for life. And what Webb found was exactly the kind of distribution scientists did not want to overinterpret too quickly, because it was too suggestive. The carbon dioxide was concentrated in Terra Regio, a chaotic, geologically disrupted region on Europa's trailing hemisphere. It was not spread randomly across the moon. It was not dusted evenly like accidental contamination. It was concentrated in terrain that already looks like a place where material from below may have been pushed upward. In other words, the chemistry was sitting exactly where an ocean trying to communicate with the surface would be expected to leave its fingerprints. This is where the story stops being a frozen moon story and becomes something bigger. Astrobiologists usually speak carefully about life, because the gap between habitable and inhabited is enormous. But the checklist for habitability is still useful. Liquid water, an energy source, the right chemistry, and enough time. Before these new observations, Europa already had two of those with confidence, water and energy. Webb just made the chemistry problem much harder to dismiss. Because carbon is not a minor ingredient. It is the structural backbone of every known form of life. Add to that the likely presence of salts like sodium chloride and magnesium sulfate associated with the same disrupted terrain, and Europa begins to look less like a sterile ice ball and more like a chemically interesting ocean world. The kinds of dissolved minerals we recognize from ocean chemistry on Earth now appear to be part of the conversation too. Not proof of biology, but absolutely not the kind of dead simplicity you would want if you were trying to rule Europa out. And then there is time. Europa's ocean may have remained liquid for around 4 billion years. That is not a brief opportunity. That is deep time, planetary time. Enough time for chemistry to become complicated if the conditions allowed it. So now Europa has liquid water, a sustained energy source from tidal heating, carbon-bearing chemistry, salts, and billions of years of continuity. That does not prove life exists there, but it removes one more excuse for pretending Europa is merely interesting in theory. Europa's surface is one of the worst environments in the solar system for humans. Jupiter's radiation environment is so intense that an unshielded person would receive a lethal dose in only a few hours. The surface is frozen, bombarded, and chemically brutal. But here's the twist that makes Europa so strange. The same radiation that destroys organic molecules on the surface may also be helping to create useful chemistry that slowly cycles downward into the ocean below. Radiation on Europa can split water, ice, and other surface compounds into fragments, which then recombine into things like hydrogen peroxide and molecular oxygen. Some models suggest that this oxidized chemistry may eventually work its way down through the ice, delivering chemical energy into the hidden ocean. So the very force that sterilizes the surface may be feeding the ocean beneath it. Europa does not behave by intuitive rules. The lethal surface may be part of what makes the ocean below more chemically alive. That is why James Webb's discovery feels almost impossible in the emotional sense. We are looking at a moon nearly 780 million kilometers away, covered in ice, trapped in radiation, and hiding an ocean under a shell tens of kilometers thick.